Good evening. Okay, is my voice audible? Yeah. Can anyone confirm? Okay, thank you. Okay, hope my screen is visible. Okay. So, good evening, everyone. So, we'll start today. Let's not waste much time. As we have given practice time for this entire week, so before you start solving the smart interview programs, we wanted to cover one more session so that most of the 90% of the topics we will cover off. Then once we come back from Diwali, we will continue with the remaining topics. Okay. So tomorrow, Tuesday batch session students go to your respective Java labs and start practicing the programs in your lab hour. So use our training session timing for 3 hours, which we are giving. So you can complete the model questions as well as start working on the smart interview programs, whatever they're asking. So this entire week, you can utilize the time for the practice. So our sessions we will resume after the next week. That is next week. That is 5th. So we'll continue again from 5th onwards. Okay. So today's topic that we want wait for the instructions. Smart Intro people will post in the WhatsApp group because till tomorrow evening there is a registration process going on. So don't do the problem solving until they confirm because we might have to reset the score. So unnecessarily you will lose the score. So wait for until they give that all students should start solving the problem. So they will message in the WhatsApp group. Okay. Fine. Okay, so in today's session we will cover recursion basics and some few programs, right? Then binary search, very important. Then stack and queue. Okay, till here it is sufficient because trees, graphs, and linked list we will keep it in the end. Otherwise, students will get confused. So until previous topic, I think we covered one D array, two D arrays, strings, loops, bit manipulation, operators, conditions, all those things. So those are the core topics that you need to prepare for the product batch. There might be few questions on binary search, stack, queue, and recursion. So let's just quickly revise recursion, solve few problems on recursion, then go to the next topic. Okay. For example, right. So what is recursion basically? Anyone? A function that calls again and again itself, a number of times, correct? So recursion is a very important topic if you want to learn these, traversal order, graph traversal order, right? So it may not be, efficient all the time, but for few type of programs, recursion is very much useful for small level programs. But we don't suggest recursion to use for like all the questions because what is the problem with recursion? all the temporary calls will be stored in the memory, right? So advantage is that you can shorten your code, simplify the approach. But the main disadvantage is what? Stack function calls. So all the temporary, function calls will be stored in the stack and accessed later. So this will put overhead, right? Because you need to process them one by one. So generally we don't use it for all type of programs, but sometimes it is needed based on the type of the question. All right. So basically what happens with recursion? Let's take one example. Yeah. Yeah. Stack Overflow. Very good. So let's say, for example, I want to take one more function called as a UN, which accepts an integer number, right? So say, for example, your input is n equal to 3, and I want to display the output like this: 1, 2, 3, and 3, 2, 1. This is your two conditions. So I want to display output as 1, 2, 3 and 2, 3, 1, 3, 2, 1, right? So you can do this printing with the help of recursion, basic recursion we are talking. So you can use two types of recursion will come into picture. So which you studied in first year only. Head recursion and tail recursion. Very important types of recursion. So does anyone remember what is head recursion and tail recursion? You mean by these are important, basics of recursion everyone should remember, and they will ask during interviews also. What type of recursion you used in your code, you should be knowing that. So suppose I want to display output like 1, 2, 3 and 3, 2, 1 using the same function in a different way, right? What is important in recursion? Base case, right? So what is base case or base condition we call it as? So it helps us to terminate the recursion. Otherwise, what will happen? If there is no base case, we will be doing infinite loop, correct? Infinite loop. So that means you will not be coming out of that condition, and your program will never stop. So like your friend said, it might lead to stack overflow also. Right. So please remember in recursion, base condition is very important point. So every time you call the recursive function call, you should be able to reach the base case. So if you're not reaching the base case, then you should not solve that particular program using recursion. Okay. So always remember in recursion, base case is very important. Base condition is very important. Okay. So say this is our function. Obviously, recursion means we have to call the same function again and again. So what is my function name? Fun. So what is that first output I want? Suppose I want 1, 2, 3, correct? What is head recursion and tail recursion? Head recursion is what? So recursive function call is the first statement, and all other statements will be processed later. Right. Tail recursion means recursive call will be the last statement. So before calling the function itself, you will process all the statements, then call the function, recursive function. So in case of head recursion, first we will call the function until we reach the base case. Then once we reach the base case, we will process all the function calls in the reverse order from the stack, right? So in this case, what is that output I want? I want 1, 2, 3 or 3, 2, 1, correct? Any one of them. So input is n and output is this, right? So tell me what could be the base case for this? So if I want to print 1, 2, 3 on the screen based on n value, right? What could be the base case? Obviously, we should apply the recursive function call, for this question. So we have to use some kind of base case to stop the recursion. So here from the main function, what you can do, int n equal to 3, and you can call that function. So we're not returning anything. So we'll be calling this function with n value. So here what we have to do. So be the base case, right? Print 1, 2, 3. Starting from 1, then 2, then 3. We have to get the output. But our n value which we are passing is 3. So here n value that we are passing will be 3. So should we print directly 3 first, or what will be the way? Anyone? Yes. No one? Generally, what happens when we do recursion? All the temporary function calls will be stored in the stack, right? So can we say if n is greater than 0, correct? As long as n is greater than 0, or you can say if n equal to 0, return. I'll just write return because we are returning void means we can't write any number, just keep the return. Suppose if n is not 0 and it is greater than 0, what we have to do, call the function with n minus 1, right? Then we will print the number, so plus n, whatever the n we are passing. So see here what happens in this case. So as you can see, we are getting the output as 1, 2, 3. So think how it is working. So whenever we are calling the recursive function call, so here this is the recursive call because we are calling the same function with the same name. Fun is my function name. Okay. And this is the base case, right? So when I'm calling the function, all the temporary function calls will be stored in the stack, right? So initially what I'm passing to the function 3. So 3 is not equal to 0. So we won't execute this condition. Then we'll go to this condition, function of n minus 1. So we are initially we called the function with 3. Then we are calling the same function with 2. Then again we are calling the same function with 2 minus 1, which is 1. Again we are calling the same function with 1 minus 1, 0. So what happens at this point? N value is 0, so we won't enter the loop function body. So we will terminate here only, correct? So here we won't print anything because we are returning from this position only. Now what happens? F of 3, F of 2, F of 1, all of them are stored in the stack frame because they have not yet processed the remaining statement. So remaining statement is the system.out.print, right? This is not yet processed. So what the compiler do is it will access all the, you know, all the temporary function calls from the stack frame in the reverse order. So we will come here. What is the pending statement? System.out.print n. So what is n value we have here is 1. So 1 will be printed on the screen. Then again we'll come back to this. 2 will be printed. Then here 3 will be printed. So temporary function calls will be stored in the stack frame This is called a stack frame, right? So f of 3, f of 2, f of 1. Then we'll print 1 first on the screen, then 2, then 3, because we are accessing in the reverse order like this. So that's why output we are getting as 1, 2, 3. So this is what type of recursion? Can you guys tell me by seeing the output what type of recursion it is? Is it a head recursion or tail recursion? So what is head recursion? I told you. Recursive function call is the first statement and all other statements will be processed later. Processed later means temporarily stored in stack frame. Once we reach the base case, the remaining statements, whatever we are having after the function, recursive function, that those will be processed later, step by step. Okay, so this is the head recursion. But now we want to do same code, same function, but I want to get the output as 3 to 1. Tell me what we can do. So in order to get the 1, 2, 3 as the output, we used head recursion, correct? If I want to use 3, 2, 1 as the output, we have to use tail recursion. Now think what is the change we have to do in the same code to get the output as 3 to 1. I want to get the output as 3 to 1. So what is the change we have to do? So assume that I am keeping the base case as it is. I'm not changing the base case. I want to keep it as it is. So obviously, as soon as I call the function with 3 value, 3 should be printed on the output. Then we have to go to the next function call, which is 3 minus 1, 2. So 2 should be printed on the output. Then 2 minus 1, 1. 1 should be printed on the output. So what is the way how to do it? Suppose if I make any mistake in the base case, if I make any mistake in the base case, suppose instead of n minus 1, I have written n plus 1. See what happens. So you can see stack overflow error. Can you see the error? Stack overflow. The reason is we are never reaching the base case. So always remember in recursion, your multiple function call should lead to the base case step by step. So if you are not reaching the base case, then it will lead into infinite loop and a stack overflow error. You will get like this stack overflow error. So what is the problem with this case is I have written n plus 1. So every time I'm calling the recursive function call with n plus 1. That is initially 3, then 4, then 5, then 6. So it keeps on incrementing, but it is never reaching 0. Ultimately, I have to reach 0, right? But I'm not reaching 0. Instead, I'm going in the incremental order. So this is a very big problem in recursion. So you should be very careful with the base case. If you're not reaching the base case, then it will lead to a syntax error or system error, right? So be careful with the base case. Yeah. So few people have given the output. So in this case, if I want to get the output as 3 to 1, the only change is I have to change the order of the function call here. First, I have to print the output, then call the function. So as you can see, now I'm getting the output as 3 to 1. The reason being, every time I'm calling the function, it is getting stored in stack frame. But before going to the next function call, which is f of 2, here only we are printing 3 on the screen first because first statement is print. Then 2 will be printed. Then 1 will be printed. Now we reach the base case. But what happens after reaching the base case? We will again extract the stack frame values in the reverse order. But there is nothing to print, correct? There is no statement below this recursive call. So there is nothing to print. That's why it is called as tail recursion. So in tail recursion, there is no statement to print after the function call. Whereas in head recursion, there will be pending statements to be processed once you reach the base case. So this much, if you know, that is sufficient for recursion. Then we can go for the problem solving, right? So recursion is very important. Please remember how to learn this, with the keeping in mind. two types of recursion, head recursion and tail recursion. Okay. So hope everyone got the clarity. So this is a tail recursive call because there is no pending statement below it. If I write it above the print statement, this is called as head recursion. So now what we are getting the output 1 2 1 2 1 3 1 2 1. So why it is happening like that? Because I am having a combination of both head recursion as well as tail recursion. So any pending statements will be processed later on. So this kind of you know output printing, they won't ask any one, they will ask. So in this case both we are combining, so generally they don't ask like that. So any one of the recursion you should know. So keeping this point in mind, so let's solve one program based on the recursion. Okay, so there is a question which asked last time called as super digit. So what is super digit? Okay, so for example, take a number. Okay, so say for example, you are reading some integer numbers, right? Then you want to print something called as super digit. So we'll call the function super and we will pass that number to it. Okay. Okay, we'll see this later. So next we say, for example, public static int. So int is the return type that we want because that answer we want to return as integer variable. Then what is my function name? Super, which is accepting an integer variable, right? Okay. Now here, what is the question? For example, you have some number 1536, right? So add all the numbers. 1 plus 5 is how much? 6. 6 plus 3 is 9. 9 plus 6 is 15. Right. Again, you are having a two digits, which is greater than 10. So you have to continue, keep on adding the sum. So again, this number, we have to add it. So 1 plus 5 becomes 6. Now, this is the question where given a number, integer number or any long number, keep on adding the sum of digits. So it is similar to sum of digits question. So you have to keep on doing the sum of digits as long as the digit becomes a single number, single digit. So that is called as a super digit. So this program generally people ask you to solve it in using recursion, for example. So how to do it? So what could be the base case? What is the logic? So we are just applying recursion into this question, right? It need not to be that you should solve using recursion only, but just understanding the concept of recursion for this particular question, right? So what would be the base case here, and till what iteration I have to keep on calling the super function, and what will be the when we will terminate the recursion, correct? So input is what? An integer number 1536. Output is 6. So yeah, you have multiple approaches, but since I'm teaching recursion, I want you guys to solve this question using recursion only. So recursion we need to apply on this question, right? We are talking about recursion. So we have to solve this question using recursion, right? What could be the base case? So we are calling this super function. So obviously till what I have to keep on adding the sum as long as the number is less than 10. Base condition cannot be n by 10 equal to 0. Base condition should be n is less than 10. Can we say like that? If n is less than 10, correct or not? Because as long as n is less than 10, I have to keep on uh, adding the sum of the digits, right? So suppose if the number is 1, 1, again it is not less than 10. So I have to again call the sum of digit function. So 1 plus 1 is 2. So final answer will be 2. Correct. So in that way, as long as your input number is less than 10, I have to keep on doing the recursion. So what I'll say, if number is less than 10, what should I return? Should I return just 0 or should I return some value? Because here we are expecting some return value. Very good. So if the number is less than 10, we have to return that number itself, right? So let me add this before the function. Okay. Public static super. Okay, so the thing is, see, we can't use the name as super because it's an inbuilt keyword. So let's use something called as super one. So there is a bracket here. Yeah. So there is a bracket error. So I'm calling the function as super one. So I think now it might work. Yeah, see, you can't use the super as the function name because it's an inbuilt keyword. So let us call it as super only, super one only. So I don't think now it is an issue. Okay. So if the number is less than 10, I will return n. Otherwise, what we have to do? So otherwise, we can keep on doing the sum, correct? So let's say initial sum value is 0, correct? So how do you take the sum of the digits? While number is greater than 0, what do you do? Sum equal to sum plus n mod 10. Why mod 10? Because mod 10 will help us to extract the last digit. For example, what is our input number? 1536, right? So 1536. If I take num mod 10, I'll be extracting this 6, correct? Then that I will add it to this sum. So we are extracting from the LSB to MSB. Then n equal to n by 10. Okay. Then say, for example, we'll print that sum value. Okay. Right. So in this case, I'm printing here only. So we have to keep on doing this as long as your n is less than 10. I mean, whatever the number we are passing is less than 10. So in this case, we have to again solve the same recursive function call, right? So return super of one of what we have to pass, sum we have to pass. So why I'm passing this sum? Because that value could be greater than 10, right? So 1536. Okay, so you can take any other number, some bigger number we will take. So now you can see it is giving me the output as 3. You can verify how. 8 plus 7, how much? 15. 15 plus 6 is 21. 21 plus 5 is 26, right? Then 26 plus 4 is 30. 35. 35 plus 6 is 41. 41 plus 7. How much? 48. So now this sum that we got, it is still greater than what? 10. So what we're doing at this point, we are again calling the super digit function with sum. So what is my current sum? 48. So for 48 we are passing again. Then we are checking whether that 48 is less than 10. So obviously it is not less than 10. So we will again do the sum of this particular digit. So 8 plus 4 is 12. Then again 12 we will pass to the super digit function. Again, this is not less than 10. So we again call the recursive call. So now 1 plus 2 is how much? 3. Correct? So as long as your sum is less than 10, you have to keep on calling the function again and again, right? Until this number is less than 10. Okay. Suppose let me comment line this. So you can verify for this. So you are getting the answer at this point also, but again, it won't return the value at all the case. You can see that it is highlighting some warning here. This method must return the result of type int. So it is only when n is less than 10, it will return. Correct? Suppose in some cases, that n value may not be less than 10, right? So in that case, what you will do? Suppose you take the input is 12, it is working. So you can cross verify your answer with some random numbers. You'll get an idea why that second call is very important, right? I mean, this particular statement is very important. So only when this fn is less than 10, we are returning the n value, or else we are computing the sum of digit. Then again recursively calling the same function here, super one with sum, not n. So this n is acting as a updated n. The sum is acting as a updated n. So we have to keep on doing this as long as n is less than 10. So you can solve this in using any other approach also. But since we want to learn recursion, how to do the question using recursion, we are learning. So last time they asked the same question in a different way. For example, now you tell me what is the answer for this is 15366. Now this we have a one more question called as magic number. Okay, so what is magic number? So after doing sum of digits, as long as your n is less than 10, if the number is exactly 1, that is exactly 1, then it is magic number. Okay, or else it is a super digit. Now the same logic, take some example. Do you have any such number? 2, Okay, 181. So what is 181? 1 plus 8, 9, 9 plus 1, 10. Now 10, again 1 plus 0 is 1. See, now this sum is exactly coming to single digit, which is 1, not any other digit apart from 1, right? So in this case, they termed it as a magic number, not the super digit. Okay, so if the returned value is exactly 1, then we call it as a magic number. If the returned value is anything between 0 to 9, then we call it as a super digit. So you can modify the same question to check whether your return value is 1. So where we can modify, can anyone tell me? Do we need to modify here? I don't think we need to modify here. So where we can modify? Yeah, 1531. 1531. So 5 plus 1, 6, 6 plus 3, 9, 9 plus 1, 10. So 10 is not less than 10. So we have to again call the sum of digit. So 1 plus 0 is 1. So this is a magic number. Okay. So can anyone try a way to modify this particular question to get this magic number? So assume that your input is 1531, output is 1. We need to modify here. Yeah, correct. So instead of printing here directly, so what we can do, only we will check that if, okay, for everyone's understanding, we can store that in some result variable and call the function super one of number. Then if result equal to 1, so let's call it as a, then what we have to print here, the result itself, right? Result equal to 1, we will print that, else super digit. From where it is coming, this output. Six. Okay, it's compiling some other question which I tried, I think. So, see, you understood what was the problem here is there is some super digit func class which already existing in my laptop in the same folder. So that's why it is printing that particular output, not this one. So you should be very careful when you are working locally. So 1536, 1531 we will try. So E6. Okay, so we are getting the answer. So we just that we have just done this question using recursion is what I wanted to explain. So let's comment line this. Okay. So let's solve one more question based on this so that you will get to know how to apply recursion. Okay, so let's take another example. So we call it as something called as universal palindrome, which I think I've already added in your model. So you can solve this question using recursion. Okay, so how to do it? Say universal palindrome means whether my input is anything, number or character or string, it should work. For example, 1221, it's a palindrome, correct? If my input is madam, it's a palindrome. Assume now I'll combine the characters 1A, 1R, R1. That is my input. Is it not a palindrome? Correct. This is also palindrome, right? So if you read it from left side also, right side also, you are getting the same answer. So it's a palindrome. Suppose I'll combine some special characters. 1 at triple at 1. And this is also palindrome. So irrespective of what is your input, whether it is just a number or a character or a combination of number and character or combination of number and special character. So it should work. So this is called as the universal palindrome, correct? So they might ask you either string palindrome or a number palindrome or universal palindrome. You should be knowing all the three logics, three different type of implementation for the same question. So for obviously for this question, our input what we have to read. Say for example, 1, 2, 1 at 1 you can take this example only take, right? Right. So this is our input, right? So with I have to read from left and right. For example, we also call it as a two-pointer approach. Very important concept in your product batch. So two-pointer approach. So we can traverse the string from both the end, that is from zeroth position also, from the last position also. Say this is 0, 1, 2, 3, 4. Right. So what we can do, say for example, there is a start pointer and there is a end pointer, start pointer and end pointer, right? So start pointer is pointing to 0, end pointer is pointing to fourth position, right? So what we can do, we can compare each character step by step, starting from end and start and end. So we will compare the character, whether they are same or not. So first character, we will compare with last character. That is, what is my first character? 1. This we are comparing with last character. So if both of them are same, then only we'll continue the operation. Otherwise, we will terminate the code, right? In this case, first character is 1, last character is 1, both of them are same. So we'll continue checking for the remaining characters because in palindrome, all characters should be, exactly similar starting from start and end, correct? So if this first and last characters are same, then we will increment start. So we will make start plus plus, then we will do end minus minus. So why end minus minus? Because after comparing 1 and 1, we have to go for the second character, which is at from the left side, and from here this at from the left side, correct? Then again we will continue searching for the next character. So in this case you can see here also we have at, here also we have at. So that means both the characters are same. We'll continue the operation. Then we will increment start plus plus end minus minus. So both of the start and end are pointing here now. So your start and end are pointing here. Now at this point, what we will do, since we reach to a single character, both start and end are pointing to the single character. we will stop the program and we will say that it is a palindrome. Correct or not? Why? Because we compared all the characters and there is only one character left. So either by reading from the left or right, we are getting the same answer. So whenever start is equal to end or start is greater than equal to end, we say that it is a palindrome. If there is any character that is not matching from the start and end, then we immediately terminate there and we will say that it is not a palindrome. So if the characters are matching, we have to increment start plus plus and we have to decrement end minus minus. So in this way, we can keep on looping using recursion. Okay, so this is the overall approach using two pointers, correct? Two pointers we call it as. Now to implement this, what you can do? Using recursion, I want to do it. I don't want to because I'm talking about recursion. So you have to keep thinking about recursion only while implementing. So don't go beyond beyond the what we are discussing the topic, right? So topic is that means you have to try to solve using recursion only. So obviously for this our input should be string, right? So string is equal to sc dot next line. So we are reading a string input. Then I'll take one boolean variable just for like different variable you can use. So we can call the palindrome function. What we have to pass to the palindrome function? Obviously, we require string. We require start position, which is 0. We require end position. So how do you calculate the end position? How do you calculate the end position? For example, 1 triple at 1. What is my end position? 4. So how do you calculate 4 here? So obviously, it depends on the length of the string. So s dot length minus 1. Why? Because starting from 0th index. So we are passing the total length of the string as the end pointer, 0 as the starting pointer. Okay. Then based on this, we will take the decision. So if we get the result as true, right, then we say that it's a palindrome, else not a palindrome. So we'll write a function here, leave static. So what kind of answer I am returning? True or false means my return type should be Boolean. Correct. So whatever the return type we have mentioned here, Boolean. So that only it should return. And for which, what is my first input parameter, which I'm passing string. So we have to take the variable string and we are calling this 0 as start position and length as end position. Okay. Syntax error. Okay. What should be this int of start, int of, because these are integer values, right? So this method must return a Boolean value. So now you can think about the logic. So I told you, right? How do you write the base case for this question? What could be the base case? If start is greater or equal to end, then what you have to do? Return false or true. You have to return true because if start is becoming equal to end means obviously all the characters might have matched except the middle character. We have to keep on doing that as long as they are equal. If they are equal, we will return true. So true indicates that it is a palindrome. Suppose if this condition is false, we will write another condition. So we will extract each character from the string. So how do you extract the character? S dot character function. So I will pass start to it. And what do you have to say? If s dot character of start is not equal to s dot character of end, right? In this case, what we have to say? Return false. So understand why we are writing return false. Because if the any one character is not matching from start and end, then we say that it is not a palindrome. For example, 1, 2, 3, 4. This is my input. Start is 1 end is 4, not matching, there only will terminate. So we don't need to check the remaining characters. So we can return false at that point itself. Right. So if this condition is false, if this condition is also false, that means both the characters are same. So we have to recursively call the same function. What is my function name? Palindrome. So return palindrome, pass the string variable. Then what did I say? You have to pass start plus 1 comma end minus 1, right? So why I'm writing start plus 1 and minus 1? So without doing this, we will never reach this base case, correct or not? Because base case start is starting from 0, end is starting from n minus 1. So both should meet somewhere, means start should be incremented, that is plus plus, end should be decremented. So that's why start plus 1 and minus 1. So as long as these two conditions are true, we keep on incrementing and decrementing n minus 1. So once we reach this base case, we will return as a true. If this base case is not yet reached, we will check the characters. While checking the characters, if any character is not matching from start and end, we will return false. That means it is not a palindrome. If this condition is also false, means we will recursively call the same function with the updated value, which is start plus 1 and end minus 1. So in this way, you can solve this program with the combination of recursion as well as two pointers. So start and end pointers by traversing from both the end. So this is the base case which I am talking. So if start is greater than or equal to end, then we say that it is true. Or you can just say start equal to end also is fine. Okay, suppose madam is my input. So I'm getting palindrome as the answer. Take some other example, 1, 2, 2 at 2, 2. Correct. So in this case, I'm combining special characters. So 1, 2, 2 at symbol and 2 to 1. So this is also a palindrome. So if I combine string also, 1, A, 1. What is happening? Exception in threadman index 4. Okay, madam is okay. So here, yeah. So since I changed the condition, so it is not working. Correct. So you understood the importance of this. Yeah, Swami has replied. So this is an important condition because we cannot say that all the time start will be exactly equal to end. So base case has to be updated properly. In this case, when the string length is becomes greater than end, that time your code will not work. So obviously this cannot be just equal to, it has to be greater than equal to. So why we got that error? I hope you understood. When start becomes greater than end, there is no, yes, very good. So it works when the length of s is odd. So only when the length of s is odd, this will work. So let's take some odd length string. 1, 2 at 2, 1. This is palindrome, right? So how many characters? 1, 2, 3, 4. Okay, in this case, 4 or 6 are there. Let's take some 1 to 1. In this case also it is working. Can you guys give me some number where 1 at 1? Yeah, in this case it is not working. See. So when it is even length, we are getting a problem because one at one means this is start, this is end. Same start plus plus and minus minus. So we will come here. Now what happens? We are passing a start plus one and end minus one. So what will be my start plus one becomes? So 0, 1, 2, 3. So start becomes 2, end becomes 1. That means we are checking whether 2 is greater than 1, but there is no such condition. So we are going to get the array index, string index out of bound error, obviously. So that's why it has to be if it is greater than or equal to the 1 at 1. So now we are not facing that issue. So you have to be very careful with the recursion base case. So if you are getting any error in recursion, 90% the error will be related to the base case only. Sometimes related to reaching that base case. Suppose if you're not reaching that base case, you might get an issue. Okay. So this is one more question based on recursion, that is universal palindrome. Okay, say for example, before I go to the next question. So let's say, I hope all of you remember the stack and queue, correct? So hope everyone remembers stack and queue. So say for example, there might be a question where they want you guys to do the stack printing using recursion. So I will give you 2 to 3 approaches for stack. So generally we have an inbuilt stack, then custom stack, then the stack created using array DQ. Okay, 3 types of stacks you should know. So if they say don't use inbuilt stack, for example, we have a stack class inbuilt, then custom stack. Then custom stack, you have to create push operation, pop operation, all those things display. So all these things should be done by the students only. So you can't use the inbuilt library. Then there is one efficient stack class is there, which is called as array DQ. This array DQ can be used for both stack and queue. So you can implement both stack and queue using array DQ in Java. So you can explore this, but read the question before solving. If they say don't use any inbuilt function, use only custom stack, means you have to create your own class using custom stack, then you will get a all test case matched. If you're using some inbuilt test case, then it won't match all the test case. So be careful with the syntax or the question what they are expecting from you, right? So if you want to use the inbuilt stack, import java.util.stack. So there is stack class in Java. You can directly use it, right? So java.util.stack. So as of now, it is saying never used. So let's use it. You'll get an idea. So how to create a stack in Java? That is the next question. So before I go to the stack, I'll give few more programs using recursion. So I want all of you guys to solve it in free time. So take some programs based on recursive based programs. Generally, they won't ask, but you should know this. Already we have solved. For example, convert decimal to binary. You have to convert decimal to binary using recursion, right? That is one question. Then recursive factorial, obviously. Nth Fibonacci number. The nth Fibonacci number means, for example, say your n value is 10. N value is 10. So how do you print the first 10 Fibonacci numbers? 0, 1, 1, 2, 3, 5, 8, 12, 13, 21, correct? So in that order. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the last number? 8 plus 1, 4. 21 plus 13 you have to do. 34. Correct or not? So in this case, if they give n value as 10, you have to return the output as 34 only. So sometimes they will ask you to print the series or just print the last number. So in this case, the series output will be 10. The 34. Correct. So nth Fibonacci series means you have to recursively keep on calling the function n time. So how do you recursively call? Two types you have to do. What would be the base case for this? If n is less than or equal to 1, so what we will say? This you already studied in first year. So return n. Correct. If n is less than or equal to 1, return n. Otherwise, return Fibonacci series of n minus 1 plus n minus 2. Correct. So every time you have to call recursive function twice. One will fetch you the second last and one is the last. So n minus 1 and n minus 2 you have to keep on calling. Then in the final result, what you have to do? Last value you want to get, right? So this value you want to get means from the main function, you can store the result somewhere and call that Fibonacci number with n minus 1. Why n minus 1? Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So 10 means I have to go from 0 to 9. So that's why we have to call n minus 1. Okay. So whatever the answer this particular Fibonacci series function returns, that you will print as a final nth Fibonacci number. If they ask you to print the series, then you can put one for loop. Iterate from int I equal to 0, I is less than n, then I plus plus. Inside this, you can call the Fibonacci series function s out, then Fibonacci of I. Why I'm passing I? Because for each number, I have to print series up to that. For example, I want to print first five Fibonacci series, right? So that means I value will be 5. So I have to keep on calling that Fibonacci number, function. So initially I is 0, will print 0. I is 1, will print 1. I is 2, will print 0, 1, 1. Then I is 3 will print 0, 1, 1, 2. Then when I is 4, we will print 0, 1, 1, 2, 3. So in that order. So if they ask you to print the series, use one more for loop. If they ask you to just print the Fibonacci number, then no need of this for loop. Directly call the function with n minus 1. Then print the final answer. Okay. But generally, Fibonacci series, we don't solve using recursion. The normal iterative approach is only better if they ask, because it won't take much time because of the stack frame. So generally, if there is a question on Fibonacci series, generally people use iterative approach only, which using normal for loop you can do. But if they ask you to do it using recursion, this is the logic that you need to apply. Okay. Then yeah, else we are having decimal to binary. So decimal to binary means you have to convert given decimal into binary. Correct or not? Using recursion. So every time you can divide a number by 2, then take the num mod 2 mod you can take. Then you can keep on doing this operation as long as the number reaches 0. Then you can return that final value as a binary value. Decimal to binary also you can do using recursion. So depending on the question, we will have to finalize whether recursion will be helpful for that or can go for iterative approach. So you can think about the time complexity. If it is not matching or getting TLE error, then you can change your approach. Okay. So yeah, we'll come back to the stack class. Right. So here, so to create a stack in Java, we are using inbuilt stack class. First, I will show you this approach. Then once you understand this, we'll go with the custom stack, how to create the custom stack. So in order to create stack in Java using inbuilt stack, so you have to use stack as the class name. Then integer indicates you that you are storing the integer values. Then st is my stack object, the new stack. Okay. So this is just like how you create the array list in Java. So it is similar way. So stack of integer is equal to new stack, which we are creating using inbuilt stack, right? So then next, how to insert the element or push operation. So you need not to write manually push code to do this. So there are inbuilt functions for that. So st dot push, if you have, right? This is the st dot push function. You can push some values to the stack. Then similarly, so I am pushing some three values. So st dot push of 30. So in that way, you can insert element into the stack in Java. Then if you want to print the stack elements directly, print the object st, which will give you the. Okay. So I'm getting the output as 10, 20, 30. Right. So again, as you saw, 10, 20, 30 is the insertion order which I inserted, but generally 10, 20, 30 is the order that I inserted, means I should get the output as 30, 20, 10, right? Because it is a stack order, which we call it as a LIFO order. LIFO order means last in, first out. So first I should print 30, then I should print 20, then I should print 10. But when you saw here, you might assume that it is linear order, but since I'm printing directly the object, I'm getting the whatever the insertion order I printed, in that order only I'm getting the output. Correct. So in this case, I want to print the stack elements in the leaf order only, and I want to achieve the same task using recursion. Correct. So what we can do? So let's say there is some function called as print stack. Right. So I want to pass this entire stack object to this print stack. So what is the return type of the stack object? Stack of integer, right? So we have to use the same parameter here, stack of integer. Then here the object name also you can use as ht only. You can use some other name also, not an issue. Then suppose before printing the elements of the stack, we can check if the stack is empty or not. So there are some functions for that. So st dot is empty. So is empty function will check whether your stack is empty. If it is empty, you can just return with the return keyword. Or else what I want to do. So let's take some intermediate variable. Then st dot pop. So there is a pop function which is inbuilt. So I want to, since display the elements in the stack order, leaf order. So the insertion order was 30, 20, 10, right? Sorry, 10, 20, 30. So I will pop the first element and store it in ELE. So what is the element that gets popped first? 30, right? So 30 gets, stored in ELE. So then once it is stored in ELE, I will print that element. So whatever the element that I had, so I'll print that element. Okay. So this is one way. Then after this, I won't stop because I have to pop the remaining elements and again print. So we will recursively call the same function print stack and pass the updated object name, right? This method never used locally. Okay, but we are using it, right? Okay, anyway, let's try to run it. Okay, yeah, that means we have not yet called that, right? So let me call that function print stack of st. We have to call it from main function, right? So print stack of st static method. Okay, so you understood these errors, right? So always when you are calling any method in Java, it has to be static method, private static. So now you can see I'm getting the output as 30, 20, 10. So that means in the stack order I'm getting. But you observe one thing, after just printing the stack, what is happening? Again, I'm trying to print the stack object. Am I getting any output here? You can see there is a empty value here. That means all the elements are popped out from the stack. There is no element left out. So I'm getting empty stack output once I write this line. But when I'm calling this print stack, all the elements are getting printed. What is happening? Can anyone tell me? So we are actually deleting the elements from the stack. But generally we should not delete the elements, right? We have to display and keep the stack elements as it is. We should not be deleting the elements that we inserted. So what will be the change that I have to do, or how to keep the original elements as it is and print the stack elements in the leaf order? I have to just print in the leaf order, then keep the original elements as it is. That should be the way, right? If I delete again next time, if I want to access or reinsert elements, then we won't be having the elements at all in the stack. So that we should be careful, because pop function will not just access, it will remove the elements from the stack. Since we are doing it using recursion, so we were popping it and printing it, then again calling the remaining stack elements with the updated object with the same recursive function call. So can you guys think how to restore the elements without actually deleting them? Can we have some way? Hope you understood my requirement. So I am getting elements in the LIFO order, but next time when I'm calling the object once again here, elements are not at all there, and we're getting the empty stack. So how do you overcome this problem? Indexing. Okay. Say we inserted 10, we inserted 20, we inserted 30. Correct? Then at this point, we are popping the elements. That means 30 is popped out and 30 is printed using S out. Right. So, so there is no element in the stack. Now what happens at this point? We call the same function again with updated stack object. That means remaining elements are 20 and 30. Fine. So we'll call the remaining elements 20 and 30. But after calling this remaining elements, again I want to push whatever we popped here into the stack. So say for example, traversing is fine. See, I'm not telling you have to do like this. Generally for stack printing, what we use for I equal to top, I is greater than equal to 0, I minus minus, print stack of I we will do. But we are understanding how to do it using recursion. Okay. So what I will do after printing the element, again we will push that element back into the stack. Can you see? So 30, 20, 10 we got in the leaf order. Then again 10, 20, 30 are getting displayed. The reason being, this is what type of recursion we call it as? Can we call it as a head recursion? If there are any pending statement, we call it as a head recursion, right? So once that work is done, right, print stack of 30, 20, 10, then 20, 10, 20, 30. So we pop this, print 30, we pop this, print 20, we pop this, print 10, right? So before going to the next recursive call, we already printing that output. Once that all the recursive calls are over, we will go back in the reverse order, correct? Then we will see if there are any pending statement. So what was our first recursive call? Originally, this was our recursive call, right? So 10, 20, 30. So after this, we will push back 30, then we'll push back 20, then we'll push back 10 again. So whatever the function calls that were pending in the stack, we'll push them back into the stack again so that original elements are not deleted. So it's simple. Once we pop, print it, we call the remaining elements. Then once the remaining elements are popped out and printed, again push the that particular function call element back to the stack. So this is one small change that will help you to restore the elements of the stack without actually deleting them. In fact, you are actually deleting, then we are restoring. You can call it like that. So we deleted here and we restored using this particular ELE because at that particular moment, the element is present in this ELE variable, right? So just one more way of printing the stack elements. See, everyone knows the normal way, correct or not? So if there is a question where print stack elements using recursion, so people should be able to do it. That's why I'm teaching this approach. So it's not necessary to print stack elements in this way only. This is just another way. Because we are not using iteration here, we are actually using recursion. So for small data size, this will be efficient only. If it is very big, stack elements are very big, then obviously this will also not going to help you because more number of function calls will be there in the memory. Hope you understood why I'm writing this st.push, just to restore stack elements. Okay, so let's go to one more program. So there was one famous question which they asked last time. Okay, so we have to sort the stack elements, right? So let's come out of that recursion now. So we'll use normal approach. So hope recursion just have this much knowledge more than sufficient. So once you get into product batch, you might be solving some programs based on recursion also. Okay, so let's say we want to sort the stack. So sort stack, right? So they will say sort the stack using temporary stack. That will be the question, right? Sort the stack using temporary stack. One more stack you have to create. So there will be one main stack like this. We have pushed some element, right? Then you will print the original stack. So whatever the original stack we have, we'll print it as it is. Then we will call the sorted stack. So in this case, let's not use for recursion. I'll use the normal iteration. So for int I equal to, so how do you get the total number of elements in stack? So you can use the object name, then size. So because we don't know where the top is pointing to, so for I equal to stack dot size, you can use I is greater than equal to 0, then I minus minus. Correct, because we don't have a why I'm using top my why I'm not using top minus one. Can you guys understand? because there is no variable in my code where I have declared the variable as top. So there is in custom stack, we can use that variable name, but in this case, I don't have top as a variable name, correct? So obviously there is only one way to get the total number of elements in stack, that is size. So once I use the size, I'll get to know how many elements are there. So basically this will be pointing to the number of elements in the particular stack, right? Then I will print the elements. Okay. How to fetch the elements from the stack? We have a something called as get function. So st.get. So get will help you to fetch each element from the stack. So st.get of I. So this is using sorted stack. So before calling the sorted stack, we have to call that function, right? Sort st, and we will pass that object to the stack. So sort st is our function name here, which we are passing the object of the stack, and this is the return type. Okay. Now, what is the question I said? Sort the stack, sort the main stack using another temporary stack. You have to create one more stack class, and using that as a input, you have to sort the elements of the stack, right? So let's create one more stack. So we call it as temp. Okay, this is one more temporary stack we are creating. Okay. So I will tell you the approach. You guys can think about it. So what we can do, the question says you have to use one more stack compulsorily. If you're not using, you won't match all the test case. So how to use the secondary stack to sort the main stack? Can you guys tell me the approach? For example, say there are 4 elements in your stack. This is your main stack. Okay, right. Then this is your temporary stack. So what we can do, we have to use this temporary stack compulsorily. That is as per the requirement of the question. And this is your main stack, correct? These are the elements in your stack. So totally 4 elements are there. So as long as your main stack is not empty, correct? What you can do, pop out all the elements from the stack. For example, 15 I will pop out, and I will compare this 15 with the existing elements in the secondary stack. So as of now, there is no existing element in the secondary stack, right? So what we can do, we will push this particular 15 into the secondary stack. Okay, so 15 is deleted. Then when we go for the second element in the main stack, which is 2. So 2 is available in my main stack. Now I'll pop out this 2 from the main stack and compare the current element in your, or we can say in reverse order. So assume that this is your topmost element in the temporary stack. This we will compare the current element with your main stack. That is, we will check whether this particular 15 is greater than current element. So in this case, 15 is greater than 2, condition becomes true. So what we will do, in this case, we will pop out 15 from the temporary stack. We will push 2 into the temporary stack. So hope you're understanding the logic, because it's a bit confusing. So if you're not understanding, you can post in the chat box. So initially, whatever the first element, we will pop out from the main stack and post it in the temporary stack. Then we compare the topmost element from the secondary stack, compare with the next element in the main stack. If it is greater than the current element in the main stack, we will delete the whatever the topmost element from the main stack and push that current element into the temporary stack. So we will do this process as long as this condition is true. That is, next we'll come to this. After that, same thing we will do. Whether 2 is greater than 1, yes, condition again becomes true. So we will again remove this 2 from the temporary stack, then push 1 into the main stack. Correct. So 1 is also deleted, 2 is also deleted. So the next element that we have is 30. Now 1 is not greater than 30, so we won't delete 30 from the main stack. We will keep the temporary stack element, which is 1, as a topmost element as it is. So we don't delete that. So what we do, as long as this condition is true, we will do that. Then whatever the current element that is there in the main stack, that will push it back to the temporary stack, right? So repeatedly we have to keep on doing this operation. So by doing this, what basically we are checking is all the minimum elements as per the order we are putting in the stack, and checking them one by one, so that when I print the output, it should be in the sorted order. Correct. So basically the minimum element should be appearing on the bottom, second minimum, next value, then 15, then 30. So we are trying to store the elements in this particular order by comparing main stack and temporary stack. So these kind of questions will be there, but I don't know whether they will ask or not. But stack programs means these are the actual programs. So not only just displaying push operation, pop operation. So you should know how to use two stacks, compare elements, then come up with the logic. Okay, so we'll just implement it so that you'll get an idea how to do it. Yeah, you can use top pointer. Okay, so just understand what I'm trying to do. So let's push some random elements. So say 5, 3, 7. So I'm pushing 5, 3, 7 into the stack. That means 5, 3, 7. So my elements in the stacks will be 7, 3, 5, right? Now this has to be sorted as 3, 5, 7. That is our main question. So I have to sort them using another stack. So while So we have a is empty function, right? So we can use that condition. So what does this condition say? If this is empty is false, if you don't understand, we can write like this. As long as stack is not empty, correct? We fetch the element and we compare with false condition. As long as it is not empty. So what I said, extract the current element from the stack, st.pop. Okay. So we'll extract the current element from the stack. So inside that while loop, after extracting the current element from the stack, we again check whether temporary stack is not empty. That is our first case. So this condition should be true. Along with that, we need one more condition. So what is that I said? And temporary stack dot peak. So we have a peak function in Java, which will help you to fetch the topmost element from the stack. So temporary dot peak is greater than current. Okay. So this is what the condition is. Right. So while temp dot is empty equal to false and temp dot peak is greater than the current. So if this condition is true, while condition is true, so what we will do, right? We will push the current element, right? Stack dot push. What is our main thing? st dot push. Whatever the temporary element that was there in the stack, we will pop it and push it back to the main stack. We will push it back to the main stack. So understand this statement. If this condition is true, we will first pop out the element from the temporary stack and push it back to the main stack. Correct? So both things I am combining in a single line. So you can separate it if you are not understanding, or else you can write like this: temp int L equal to temp dot pop, and then we can pass that temp to here, the TL to this. Both are fine. Okay. Only if this condition is true, we have to do this. Suppose if this condition is false, we have to push the current element back to the temporary stack. Okay, so by doing this, we are actually sorting the stack elements. So I'll just execute and show you. Yeah, so one more part is missing. So after doing this, we have missed out, you know, one more important condition. Okay, so as you can see, I'll explain that last while loop. Our actual stack elements are 537. Sorted value I should get as 357. So in this case, we are not using any sorting algorithm or something. Just the question says you have to use two stacks. That is, you have to keep it in mind. So using two stacks, we have to do this operation. So now you can check the logic, how it is working. So let's take our input 5, 3, 7. That's what we inserted, right? 537. So you check the condition. Now main stack is not empty. So we'll fetch the current stack, right? I mean the pop we will do and fetch the current element, which is 7. Then we will check whether temp dot is empty equal to false. So initially our temporary stack is empty. So this condition will be false. So we'll directly push that 7 into the temporary stack. So 7 will come here and this will be deleted. Okay, next we'll go back to the main loop. In this loop, we will fetch the second element, which is 3. Now this condition is while temp dot is empty equal to false and temp dot peak is greater than current. So tell me what happens at this point. So this condition is also false, right? So while temp dot is empty equal to false, this condition is uh, false, and this condition is true also, doesn't matter. So we'll directly push again the next element into the stack, which is 3. Then we will once again go to the main stack, fetch the 5. Then while temp dot is empty equal to false, right? So again we will push 5 into the third stack, I mean third element into the second stack. So now at this point we will reach this uh, condition becomes false. We will come and right, and one more thing we missed, this part we missed. So what happens here is every time we are pushing, we are checking the condition whether temp dot peak is greater than current. So once this condition becomes true, whatever the element that was there, so that we will replace with the current element, right? So see here, temp dot pop means we will for example comparing these two, 7 and 3, 7 will be replaced with 3, correct? Then again since 3 is not greater than 5, so it will remain as it is. So in that way, 3, 5, 7, the second stack we are updating. So we just need to, this is important to store the original elements back into the main stack. So this is not mandatory, but to store the temporary stack elements back into the main stack, we are writing this code. Otherwise, you can print directly the temporary stack elements. That is also fine. So here, if you directly print temp also, you get the answer. Okay, so as you can see, I'm getting 357, but in the sorted stack from the main function, I'm not getting any answer because we have deleted all the elements from the main stack, right? So all the elements are now in the temporary stack. So this you need to be careful. So if they say you should not delete the original elements, means we have to push it back into the main stack. So as long as temporary stack is having elements, we can pop them and store back into the main stack. So st.push of temp.pop means, so we are popping the temporary stack element and pushing into the main stack. So you can combinedly write like this, or you can write separately. So this logic is a bit difficult, but this is how the questions will be. So you have to practice to understand how the operation is going on, how they are comparing each element one by one. So can you guys tell me what does this is empty function will return in this case, right? So hope you are understanding the logic. So here we missed out on this, you know, we inserted 5, 3, 7, right? So initially 7 will be in the temporary stack. Next element that we are getting is this is deleted 3. Now this temp.isEmpty is false and this is also false. So this condition actually becomes true. Then we go to this condition, right? So in this case, what happens? Temp.peak is greater than current. So what is my peak element in the temporary stack? So this is temporary stack, right? Peak element in the temporary stack is 7. So 7 is greater than 3. Condition is true. So we enter the while loop. Then we pop out the temporary stack elements, which is 7. Then we push that element back into the main stack. So see here, that means 7 was deleted. 7 was deleted. We are again reinserting back into the main stack. So this is also deleted. So now 7 is coming here. Now we keep on doing this condition as long as this is temporary stack is not empty. So after deleting the 7, again this became empty. So we will come out of this inner loop. We push back the current element into the temporary stack. So what is my current element in the temporary stack? 3. So 3 will be inserted into the temporary stack. So this is how it will be. Now what are the remaining elements in your main stack? 5 and 7. So again 7 will be become my current element. Now 3 is not greater than 7, so we don't touch this element that is there in the temporary stack. So this condition becomes false. So what we do, we keep that temp dot push of current. That means 7 we will delete and push it into the temporary stack. Now the remaining element in the main stack is only 5. So we will compare 3 with 5, correct? Now again, temporary dot peak is what? 7, not 3. So 7 is greater than 5. Condition becomes true. So we pop out this 7, push it back to the main stack. So again, 7 comes back to the main stack. Then this 5 goes into the temporary stack. So temp dot push of current means this 5 goes into the temporary stack. So now 3, 5, 7. Then we'll again go back. Current becomes 7. This condition becomes false. So we will push 7 into the temporary stack. So now you can see the order. So 3, 5, 7. So in that way we are sorting. So it takes some time to understand this kind of logic. So you have to trace it step by step. Then definitely you'll get a clarity. So this is one type of question which you will get in stack based question. So few more questions I will give you, so you can try to solve it. I will conduct the session in the coming weeks again, as we are running out of time. So you can take down the question, stack-based programs. Few more questions I'm giving, you can solve it. If you're not able to, then we can discuss those in the coming sessions. Hey guys, I think there was power off, so just a second, I'll give. Is my screen visible? So as I was saying, just take down these few questions and work on in the next few days. Okay. Similarly, like sorting, sort the stack. They might ask you to find minimum element in the stack. Find minimum element in the stack. So what do you mean by minimum element? Uh, Again, this you have to use two stacks. All these are two stack approaches. Find minimum element, sort stack. You have to do it using two stack. You might think finding minimum elements are what is a big deal. I will compare each element using index, and I will store whatever the number lesser than the previous number. I will update as a minimum. That is the normal approach, correct? That I hope everyone can solve it. But they will give the question like this: sort using, I mean, find the minimum element using two stacks. So your program should use two stacks. Then implement custom stack. This is a very simple question. Implement custom stack means in Java you can go through. In W3 schools also you have a example. So custom stack in Java. This is normal implementation, so you need not worry much. How to create a custom stack you can get from any website also. Sometimes they say don't use inbuilt function. That time you have to create a custom stack. So for example, this code you can just practice, right? So you are creating a class stack. Inside that you are creating an array, right? Then top is pointing to the current element. Capacity is total capacity of the stack. So this is a custom stack where everything you have to implement: push operation, pop operation, display, empty function, full function. So this is a normal way of implementing the custom stack. So if they ask custom stack, you have to write everything, implement all functions. So then, as I told you, stack using DQ. This is most efficient. If they have not mentioned that you should not use any library function or inbuilt stack, you can use directly DQ. Just like your normal stack, DQ can be used. So similarly, I will give queue-based questions. You can try. Okay. Like I said, for stack, custom stack. Similarly for Q, custom Q, then reverse first k elements from Q. Reverse first k elements from Q means what you need to do. Suppose if your Q is having 2, 3, 5, 8, 9, and k value is 3. That means you have to reverse only these 3 elements. That means output should become 5, 3, 2, 8, 9. So this you should not reverse. This value should be reversed. So custom Q, they might ask reverse first k elements from Q. So generally, I have not seen any question based on Q. So this basics is more than enough. Then similarly, trees and graphs, just go through basics of traversals, pre-order, post-order, and all. Then BFS, PFS. Okay. So similarly for linked list, delete middle element from linked list. Right. Then transitive closure, detect cycle in graph. These are all some of the important questions on trees and graphs and linked list. So linked list, don't worry much. They won't ask deletion, updation, and all those things. Just traversal of the linked list, maybe creation of the linked list. That's all. They won't expect any higher level implementation from 2-1 people. So this much is more than sufficient. So this remaining topics I will cover once this week is done. Once I come back from the holidays, different holidays. So I will continue with the remaining sessions. So till that time, just go through the basics of stack queue and recursion what I discussed today, and these questions what I gave. Some of the important questions. Then balanced parenthesis also very important. Balanced parenthesis, infix to postfix, evaluation of postfix expression. So this much is more than sufficient for stack programs. Nothing else you need to study. This much is sufficient because they might ask or they may not ask questions based on stack. So don't waste too much time on DSA, basics of DSA. If at all, if they ask, you should be knowing how to implement this kind of questions. So these are some of the points I wanted to mention. So try to practice, utilize the lab timing from tomorrow. All this. So those who are having session on Wednesday, you can directly go to your labs and practice the programs. Similarly, those who are having session on Thursday, you can go to Thursday lab morning. Okay. So for any doubts that you are getting for assessment related, exam related, registration related, post in the group only because they have the authority to reply. We don't have any access to what is the issues you are getting in the smart interview registration process. So from when they will update you. So wait for their instructions. Or upload this video in YouTube. Definitely, sure, I will do it. Okay, all the best. I'll continue once we come back from the holidays. Okay, thank you.